Hi, so in this video we are going to talk about the components of a simple circuit that turns on and off an LED using an Arduino. So the first thing we need to talk about is what is Arduino, what does that even mean? So let me go ahead and scroll down here. Okay, so an Arduino is a tool for controlling electronics. So over here, I have a picture of what an Arduino kind of looks like in real life. It is able to read inputs, so sensors, temperature sensors, push buttons, user input. It could be from a code that you write as well, and it will, from your inputs, create a certain output. So we're going to make a very simple circuit this week using an Arduino that can turn on and off lights based on different inputs. We'll make a series of different circuits with different inputs and be able to control LED lights. We are not meeting in person, so we are going to use Tinkercad circuits to create on the computer a circuit that is going to act similarly to how it would act if we actually physically built the circuit. So the Arduino board on Tinkercad looks like this, and there's a couple things I want to know. So we have a USB port on our Arduino. Okay, that's where the Arduino can get power. It also can get power here. Okay, but that is how you would connect it to your computer and get code that you have written onto the Arduino board. Okay, so the Arduino has like a mini computer right here, a microprocessor that you can code, and depending on what you want your Arduino to do. So that's a pretty useful that makes Arduino a useful tool for a variety of different projects. So a couple of the key pins that you need to pay attention to, because you will be using them in the circuits that we build, are the ground. So here is a ground right here. That pin, you're going to want to connect your circuit to ground. So definitely we'll be putting wire in there. You also have power source pins, so you can supply 3.3 volts to your circuit by directly putting a wire into that pin, or you can supply the circuit with 5 volts by connecting it to that pin. Okay, you also have over here a bunch of different pins that are output pins, so you can supply power at only certain times depending on your code. So these pins over here can be a power supply to your circuit, but those are the output pins from like what you've coded your Arduino to do. So they won't always give you a voltage depending on what you've set up. And I think that's all we're going to be using. So those are kind of, the analog in over here is worth mentioning. This analog in section, so the Arduino can read like temperature sensors, pressure sensors, all different types of sensors that would maybe have an analog input. It can read and create outputs based on what those inputs are. So there's definitely a lot more information about Arduinos posted online. If you're interested, I'll link a couple things in the description so you can take a look at them. So in our circuit, our main output is going to be an LED. So we're going to have a light emitting diode. So basically just a small blinking light is what we're going to end up with at the end. First, it'll just be constantly on, and then we'll figure out how we can make it blink and how we can control it with a push button. So there's a couple important things you need to know about LEDs. So LEDs, you'll notice, have two different leg lengths. So what LEDs actually look like would be over here on the right. They look like that. They'll have one leg that's slightly longer than the other. Here, the longer leg is this one. This is what the LED lights will look like in Tinkercad. So the longer leg is your anode. Okay, so you're going to want, that's your positive lead or positive side, and the shorter leg, the straight one here, is going to be your cathode, or the negative side. So when making your circuit, you want to make sure you connect this side to the positive side, okay, the right side to the positive side, and this left side over here, the shorter leg, the one that's straight, to your ground or your negative lead. The other important thing to note that I've written up here at the top is that LEDs only work for a specific range of currents. So you are going to need to modify your circuit with a resistor to get the appropriate amount of current to run through your LED. That resistor is going to be connected in series with your LED in your circuit. And a quick review of resistors, I know we worked with these in class, but resistors will resist the flow of electrons, so we're going to use these to actually decrease the amount of current flowing through an LED. We're going to add a resistor in series. The higher resistance that resistor has, the less current is going to flow through the LED. So for example, you might have an LED that can have no more than like 20 amps run through it, or 20 milliamps run through it. But if you apply 5 volts to that circuit without a resistor, okay, so let's say we applied a voltage of 5 volts directly to this LED, okay, and then we didn't have a resistor, the current is going to be way too much and you're going to basically fry your LED, okay. Well, we'd have to close the circuit for that to fry, but you need to add a resistor to reduce that amount of current flowing through the LED. You also need enough current to actually make the LED like not so dim. So it'll be very dim if it has a low amount of current flowing through it, lower than it wants, or it might not even turn on at all. Okay, so those are LEDs, and those will always be paired with a resistor in series, so that we can get the appropriate amount of current flowing through it. And the last thing I want to talk about before we go into breadboards, how we're going to put all this together, are push buttons. So push buttons basically act like a switch. So you're going to have a button that looks like this, and in real life you'd actually push the button down, and that would complete the circuit and push the switch down. So this would actually, when you push the button down, that closes, and then you have a completed circuit where your current can flow through the circuit. Otherwise, there's a break in your wire and no current can flow if there's a break in the wire. So a push button, fairly simple, just acts as a switch. Whenever it's pressed down, current can flow. Whenever it's not pressed down, current cannot flow through that part of your circuit. Okay, the final thing I'm going to talk about are breadboards, and I'm going to link much more information in the description. I know a lot of you have probably worked with breadboards in the past. If you have not, it would be a good idea to look at the extra video that I posted about breadboards. But I'm going to talk about just the very basics. So basically, your breadboards allow you to quickly build or quickly prototype a circuit that you want to make permanent maybe in the future. So you can think of these little pinholes as different areas that are like connected by wire, kind of. So in this first diagram here, I have all of these kind of circled with green. So that means all of those pins are basically the same wire. They will all be connected to each other. So if I supplied 5 volts, connected a power supply of 5 volts here, if I connected something down here, that would also be at 5 volts. Okay, so if I connected another wire coming out of here, because it's connected, well, it has to actually be in the pin. I'm struggling to try to get that to actually connect. But if I connect something else into a pin on this rail, that will also be at 5 volts. They're all electrically connected there in that column. Okay, and then across each row, okay, there's 5 holes that are all connected electrically together. So any 2 things that are connected here are basically connected by the same wire. one thing to note is this connection does not cross over to here. Okay, so you're not going to, like F, 1F is not going to be electrically connected to 1E. There's a different set over here of poles that are all connected to each other. Okay. So, again, if you want more information about breadboards and how to use them, look at the description in the video and there's a link. But I hope this was helpful, and this is building up to what we're going to do in the next video, which is go through and use Tinkercad to build a simple circuit that can turn on and off an LED.